Alright, let's look at example 2 with geometric sequences. Okay, again, the directions are we're going to find the explicit formula, the recursive formula, and then we're going to find the 10th term. Now, if we look at our sequence here, we have a negative 3, 12, negative 48, and then positive 192. So it's alternating between positive and negative numbers. So what that means is our common ratio is going to be a negative number. Again, our common ratio can be found by taking two of the numbers in sequence and dividing them. And again, in this case, it may be a little bit straightforward to find it, but we'll go ahead and go through the process of setting it up to find the common ratio. So in this case, our common ratio, which we're going to denote with R, is going to be 12 divided by negative 3, so we end up with negative 4. Okay, in this case. So that's our common ratio, which will be used in both the explicit and recursive formula. Let's go ahead and find the recursive formula. Okay, with the recursive formula, we're going to use the general form of a sub n is equal to r times a to the n minus 1. Okay, and then we need to list the a sub 1. So in this case, a sub n is equal to r, which again was our common ratio, which is negative 4, times a sub n minus 1, and then our first term was negative 3, so we list that as negative 3. So that is our recursive formula for this particular sequence. Now our explicit formula we're going to find by, again, using the general form of the equation, which is a sub n is equal to a1 times r to the n minus 1. Okay, now in this case, we know r to be not negative 3, r is negative 4, so excuse me. So a sub n is equal to a1, which is negative 3, times r, again, which is negative 4, to the n minus 1 power. So that's our explicit formula for this particular sequence. And then our final step is we're going to find the 10th term. Now to find the 10th term, we're going to take negative 3, and then, because that's our common, that's not our common ratio, that's our a1, times negative 4 to the n minus 1 power. So we're going to take n and replace it with 10. So we'll have 10 minus 1. So we have a sub 10 is equal to negative 3 times negative 4 to the 9th power. Word of caution, with some of the calculators, you have to be careful on how you put in a negative number when you take a power. Now, this is a odd exponent here, so we should end up with a negative number when we do it, the power. So negative 4 to the 9th power should give us negative 262,144. Now, when you're doing these in class, you can go ahead and put all this in the calculator, come up with the answer. You don't have to go through the steps. And then we're going to multiply that by negative 3 to get our 10th term. So we're going to end up with a positive number here. So we end up with a sub 10 is equal to 786,432. So as you can see from our examples, with geometric sequences, the terms can get really large or really small in a relatively quick amount of time. But again, now we found the explicit formula, the recursive formula, and then a term in the sequence.